I built this too, which is a AWS Cost Monitor. It's not a really complex service. It brings data regarding costs from AWS and from another service into Slack notifications. And when I built it, I thought that it could be useful for some people to learn on how to do that, and also to send stuff into notifications on Slack. So yeah, I thought it would be useful. So that's what I'm going to present here. So our problem was, the client problem was that our production account was really increasing in cost, mainly because we were scaling on the EKS, both horizontally and vertically. We were having to like increase machine size and increase the numbers. And yeah, we had like a specific budget, and we were surpassing it, and like we're not having a control of it. You guys can see like in the bars, I'm hiding the numbers, but you can see in the bars that the values were like almost doubling every month, and we're not getting track of it. So yeah, there is a tool on AWS, which is the Cost Explorer, which is also called Cost Manager, which is where I took this screenshot from. It's a good visualization tool. It has like some reports that you can build, just like a BI tool. But yeah, you can like really customize it, and you also you can bring notifications from this report to Slack, but it's a lot harder than to just do an API request to the service. So yeah, the idea was to build our own service that will do that, and also weekly granularity, because Cost Manager works as hourly, daily, and monthly. And yeah, I thought that like weekly would give us a better tool to visualize it. Also, as I mentioned, like most of our costs would come from EKS, and there's a really good open source tool that AWS recommends, which is called KubeCost, that stratifies the cost from your cluster. So instead of having like the whole account as the Cost Manager / Cost Explorer does, the KubeCost does the same, but for your cluster. So it can tell you like which namespaces are you spending the most, and what is your cluster efficiency. Because like the cluster, if you guys are not like really aware of it, a Kubernetes cluster is like a group of machines. So you tell AWS that you want like 3 machines of M3 large, let's say. And if you don't spend it on using resources, you will pay it like in the same way if you pay them on demand, which is usually the case. So yeah, KubeCost is good for that, because you can know like how what is the percentage of machines you're actually using through days and weeks. So why not bring this data also into the same report that we're going to build, right? So let's go into the demo now. I'll show you guys the code for that. So here's already the repo. You guys can check it whenever you want. Here I have like some Kubernetes resources. I'm going to go into that later, but first I wanted to show you guys the code. But something that I really like that data engineers do not like much is to show stuff on Jupyter, because I think that's like really easy to educational wise. So I'm going to like show the code, the primary code that I kind of produced to show you guys, and like all of the steps, and then I'll go into the functions. Yeah. So basically, like the whole code are these two Python script files. So we have the helpers, which are functions that help me to execute like the whole process here. And yeah, I'm not going to run like the main here because we would need a AWS account, and I wouldn't want to like bring the client data. So I did something that is pretty similar. I ran this and changed some of the values, so you guys will see it like almost completely as I would run it. So yeah, basically we have like just Boto3 request because yeah, Boto3 for reaching the Cost Explorer API and the request for the Slack notifications. So yeah, here I just specify the range of the date. I have to put it into a dictionary because yeah, that's to reach the Customer Explorer client, you need that. So yeah, I put that as a markdown because I didn't want to run it. But yeah, you guys can see that I create a session, like pretty easy stuff for people that are already familiar to Boto3 on Python. But yeah, there is a method here that you ask for the cost usage. Usually you want, so here you guys can see that I'm specifying the time period. The granularity is daily. As I mentioned, like they don't have weekly, but what I do is I get this data daily and then I sum it because I want it weekly. The metrics, like there's a lot of costs that AWS returns to you. Like there are costs before taxes and stuff like that. So usually you just want unblended costs, which are the actual value that you're going to pay in the end. And yeah, here I just want to group by service. So yeah, I created Dict just to tell that I want the dimensions to be the service. I already, as I said, like I already created the dictionary. So as you guys can see, a mock one. So that's how AWS returns that data. So as you can see, I already specified that I just want it by service. So it brings like the name of the service and the amount in USD, right? So pretty simple, and it returns like it divided by days. So you guys can see that there is one date for there's some nested digs here, but there are some nested dictionaries, but one of them is for the 20 to 21 because it specified 20 to 22, right? And another one for 21 to 22. So yeah, here's an example of of what I get from the API. Here on the helpers, I have a function that organizes this dictionary and it becomes like this. So it's just like a JSON treatment. As you can see here, like I'm not going to go deep in what it does. I think it's pretty clear. As you guys can see, like it sums all the data and simplifies the JSON. Here I just order it and I sum it. So yeah, you guys can see like in this mock, the ECR is the most expensive, and then Kinesis. And yeah, here in this part I transform this into actual strings instead of JSON because in the in the near future this will become a Slack notification. So I would just pass it as string. And yeah, here, like I just run some similar stuff. I run like the exact same functions, but for a period that before that, because I want to compare, like I want to know if the costs are increasing, if the costs are decreasing. So I compared those two periods. So here I just run basically the same functions, and yeah, like here just um, uh, I compare them, and like I calculate the percentage of the difference between them. And as you guys can see here, I create a list of strings to pass to the function that is going to create the Slack message. So yeah, cost report for account X between those dates, total cost, the top 5 services sorted by cost, and compared to the week before, cost decreased by an Y amount in a Z percentage difference. And here's the code that creates the Slack message. And here I printed it out, as you guys can see. So here I specify the channel, the username, which is going to report that. And then each value from the list is going to be a specific section, as you guys can see. So that's why I put it in a list. The function will get this list and will like create a header, and then a part that will go on the bottom, and then we'll fill it out with the messages that I just created in the middle. So here I can like create a list of anything that I would want. And yeah, here's the final result. And here I put it as a markdown as well, but you can configure a Slack. You can get actually a URL for Slack, which you can request. You can do just a API post, and you just send a message. It's pretty simple. So here I have the URL, which is like an environment variable in the system. But yeah, so I just dumped this Slack message that I created, put down the headers, and this is the final result. So yeah, this is kind of what we get. Also, there is the cube cost that I mentioned you guys too. That I'm not showing you here because it's kind of redundant. Like the code is pretty similar. I do an API request, I twist the JSON, and then I append it to this text messages list, which will be sent to the Slack function. But you guys can see here the final result, like the top 5 services sorted by cost. And yeah, it does like a message here which tells you what is the actual percentage of the idle cost. So yeah, that's about it. So here's the main function. As I mentioned, like I couldn't run it because I would actually have to gather the API request, but the code is pretty similar. But the difference is that it gets the dates automatically and stuff. I don't have to manually input them. And yeah, you guys can check it out later if you're interested on that. It shouldn't be hard to apply it into a different client. You just have to like to create a new Slack webhook and stuff. And yeah, the helpers function, as I already showed, are just like functions to treat the dictionaries, the AWS cost, the cube cost, and summing the dictionaries and creating the Slack message. Yeah, so besides the AWS costs that are here, I have some configuration for Kubernetes. So the stack, like the infrastructure that I'm actually going to go into the next slide, which I talk about this, but this is the deployment infrastructure. I actually create a Docker image based on the actual, based on the code. So you guys can see here that there is a Docker file, which just like installs the library and runs the main Python script. And I do that because I run this is a cron job on EKS, and for a cron job to run, it needs a Docker image. So I create an image, I deploy it to ECR, and the cron job together with a config map that has all of the environment variables. It runs it weekly. It's on every Monday, if I'm not mistaken. And yeah, it does an API request to both Cost Explorer and KubeCost, and sends it in the end as a Slack notification. What I was going to also show you guys is the EKS configuration, if you're interested on that. So here's the template, the YAML for creating a cron job. It's pretty simple. So as you can see here I specify the CRM image. I just put down a name to it. I specify which config map on my system has the environment variables, which are like the Slack webhook and where is like the KubeCost IP address as well, and the cron schedule. So yeah, here it is. And yeah, that's about it for the infrastructure. Yeah, also like not everyone will have an EKS where they deploy that. So probably like the first solution that I would do to implement it would be on Lambda, which is like a serverless computing service from AWS. But since we're already running a lot of stuff on EKS, it would be better to keep it there. You can also run a cron on EC2 if you already are working with EC2s, or you can run the container. You can read the image directly on an ECS. So yeah, there's some other options for that. Just running basic Python script. And yeah, I already showed the print screen on the Jupyter, but yeah, these are here's the actual Slack notification. We are actually doing that for two different accounts, but I can plug it on the go for different accounts because the work is kind of already done. And yeah, I already mentioned that we're running it into accounts. So what was one of the conclusions we got from that? We saw that there was a lot of FIDO processing on REKS, and so we started deploying a EKS auto scaling tool, which it does exactly what I mentioned. It instead of you specifying the number of instances and the type of instance you want previously, Carpenter will take care of this, which is the tool I chose. So it will you can specify in Kubernetes like how many resources will a pod or a job spend. So let's say your current jobs right now are needing like 10 gigabytes and 10 gigabytes of RAM and like 2 cores of CPU. So Carpenter will know that and will scale it based on your request and based on some other stuff. Like there are some pods that need to run on the same EC2 machine, and so on the same node actually, which is the EKS name. So yeah, it's way better to have a tool that does that for you because you spend a lot less resources. And yeah, that's about it. If you have any questions, please let me know.
Go first, Sebastian.
Yeah.
Okay. So first question is, what is the level of granularity that you can get from these reports?
You get, I think the least granularity you can get is hourly. So yeah.
Got it. And can you drill down below the service granularity?
Yeah, there's a lot of dimensions, I think, like you can get. So I think there's some documentation for that. So yeah, you can get by instance type, instance family, operating system, usage type, region, resource ID. So yeah, you can get by a lot of stuff. I didn't want to go into too deep into that on the script I built, but yeah, you can do that if you want.
Got it. Yeah. So once you have like some spike in the cost, you wanna do a little bit more research, and this information is, yeah, you can drill down through all of these levels. So
Yeah.
makes sense.
Mm-hmm.
Thank you.
No worries. Yeah, something that I didn't want to, I actually didn't want, no, I forgot to mention is that it has some cost to it. It's not very high, but I think it are like 2 cents per request. So yeah, just something that it's worth mentioning. But let me check if I find the cost. But I found it funny that they charge per API request. Yeah, it's 1 cent per API request. So yeah, that's something that if you guys if you want to run it, don't run it per minute, because the least granularity is hourly, and you just spend money. Actually, it's 1,000. It's a cent for 1,000 usage records. So yeah, it's pretty cheap. But it's funny that they charge for it, and probably lots of people spamming the API.
So Gabriel, I saw that you mentioned that you like the built-in tool that AWS has does not have a comparison or a granular comparison, but I saw in that screenshot you shared it was comparing to the previous month. So is it that it only compares to monthly or what?
Yeah, it can create a comparison, but it compares like different days, and it can compare different months and different hours, but it couldn't, like, you couldn't customize it to specify time frames from what I saw. And yeah, so kind of that's why I created this script. But you can like run it like a BI tool. Let me see if I can show an image of it. Like, yeah, that's a good one. You can specify uh, the you can specify like the dimensions here, like everything I would do through the API, you can do here through the API service. But yeah, it doesn't have like a specific granularity that you'd want. Let's say if, each 15 days or weekly, you just have like daily, monthly. And it also like didn't have a direct integration with Slack. You'd have to set up SNS for that, and you wouldn't be able to customize it as much as a programming script. So yeah, but you can do like a lot of stuff inside the service. Like it's a good service. AWS lets you customize it a lot. It reminds a lot like a BI too.
Got it. And do you have any plans on extending the tool? Maybe send all the data to Snowflake and then create custom reports out of that, or would be too much of a overkill for it?
No, I think it's a good idea. I was actually thinking about this in the beginning, sending the data to Snowflake, because I don't know if AWS saves the data like for permanently. But yeah, that's a good idea. We don't have much plans to it. Like our resources currently are being put into making the auto scaling to work. It's already running on staging, but since we don't want to make the production environment to have any downtime, we're still thinking of ways on how to implement it there. But yeah, I think sending that data to Snowflake should be a really good thing to do also, because it would maybe also getting doing API requests to Snowflake to get the Snowflake costs as well, because they are separate from AWS. So yeah, I think that's a good idea of a next integration.
Another suggestion for extension, Gabriel, it's starting have like predictive scenarios, like to try to forecast next month or future dates of. We could even have some support for a couple of data science that we have here, but I don't know if they got very happy when he said that Jupyter is only used for play around. But we can try to find volunteers if in case you want to move forward with that.
Yeah, yeah. Maybe AWS disagrees with me. There's SageMaker that it's increasing a lot on usage. Is that data engineers usually don't like to use it that much. But yeah, maybe like we could run just a profit there on the dictionary and try to estimate like next periods. I think that would be a good idea.
Yeah, I guess Seba has a hint.
Yeah. Another question. So based on your experience on the tool for now, what were the most costs or services that you find most impacting in your project or the two projects that you implemented so far?
Yeah, so basically our infrastructure was being hosted on EKS. So for you to run EKS, I think you just spend like 10 cents per hour, if I'm not mistaken, on the like a base cost that AWS asks for. So it's not that expensive. The real costs are the nodes, which are EC2 machines that AWS put in your cluster. So yeah, that is most of the costs from the account are it's the EC2 instances. But regarding pods inside the EKS, the actual services, most of our workloads come from Airbyte. We do a lot of transitioning between Postgres instances and Snowflake. We're creating a data warehouse, so we send a lot of that data, and some of the data is being sent like for each 10 minutes, each 5 minutes. So and some of the workloads are really big. So yeah, Airbyte usually gets most of the cost there, and it's good to have an auto scaling tool because maybe some of your workloads, like the bigger ones, will just run once a day, and you just don't want to have the EC2 instance running all day if you're just going to run the job once. So yeah, mostly Airbyte inside the EKS.